My name is DeDolph and I'm an engineer with NTN Corporation, a supplier of tapered roller bearings to the heavy-duty truck industry. Today we will be discussing the appropriate method for mounting bearings inside the wheel hub to achieve the desired 1 to 5,000th worth of end play. In the course of that discussion we'll be referring to a couple of TMC recommended procedures, RP618 and RP622. So, in talking about the wheel end, there are two tapered roller bearings inside the wheel. Most of you probably refer to this as the bearing and this is the race. Us within the bearing industry calls this the cone and this the cup. Again, NTN Bauer is a maker of these tapered roller bearings, made here in the United States, made of case carburized material. Why do we use case carburized material? The main reason for that is it results in longer life in operation and it's much more resilient under high impact or heavy duty loads. In case carburized material, the exterior of the bearing is hardened to a very high degree and the inside is relatively soft. And you can think of it as acting like a shock absorber, so as the truck's going down the road and running over potholes and what have you, and large loads are running into the bearing, it can take that much better. This is in comparison to through hardened taper that's common from overseas suppliers, where it's hardened to the same degree all the way through. So your case carburized material gets you, roughly speaking, 40% longer life than a through hardened part, and it also gives you much more shock resistance. Additionally, testing we've performed shows that when you load up this rib flange here, which in the wheel, we have our wheel, we have our inner taper, our outer taper, and our nuts. The rib flange is right here. The rib flange, when you cycle load on that rib flange, a case carburized part can last for roughly 100,000 cycles. Through hardened parts from overseas suppliers that we've tested have lasted for roughly only 10,000 cycles. So 10 times longer life. You're probably asking, okay, so why should I care? Well, that rib flange is right here. If this should break off, there's nothing holding the rollers in the bearing in. Those rollers fall out. And when those rollers fall out, there's nothing holding this hub on the truck anymore. And that's when you have your wheel off situation. So, with the RP618 and 622, we'll be dealing with the old dowel pin style system. You know, our adjusting nut with the dowel pin, the washer, and the jam nut. So when we go through our procedure, keep in mind this is what we're talking about. For those of you who have started to see some of the newer single nut systems out there, we'll discuss that at the end and what that means as far as the procedure is concerned. Before we can put the new bearings in, we have to get the old races out. So we'll have our hub here. We've gotten the hub off of the truck. We'll have removed the races from the hub. And what you want to do is you want to check the bearing seats, or where those races were sitting in the housing. You want to check for stuff like corrosion or fretting corrosion. It's an orange buildup. And you want to kind of rub that away and any kind of damage to this hub. The reason for that is these races are elastic, which is just a fancy way of saying they'll take on the shape of whatever this housing looks like. So if there's a lot of dirt and mucked up material on here, you will push this race in and it'll take on the shape of what that housing looks like. So you want to take like Scotch-Brite or something to take away that fretting corrosion. Additionally, if the previous installer had the race cocked when they pushed it in and rolled up some material, the new race will go over that and you'll have a kink in the raceway. It's an area where you're more than likely to have a very early failure. So you want to check to make sure these bearing seats are clean. There's no damage to the shoulder where the bearing's going to butt up against, so that when you push it in, it'll be nice and flat. So we check our hub and make sure everything is nice and ready to go. If the previous hub is damaged enough, you may want to think about replacing the hub. We at NTN have gotten some questions from technicians. It's like, our practice is to always replace, when we replace the bearings, replace the races. As a bearing manufacturer, that is the way we want you to do it too, but sometimes there's pushback from independent fleet operators who are looking for ways to try to save money. Our standard is, even though the race looks good, a failure mode in bearings is called flaking, where a piece of this raceway will come off and it'll look like a pothole on the road. This race can look perfectly fine and you can be a couple hundred miles away from that flaking happening. So the best bet is when you pull off the bearing, replace the race. Mainly, this price-wise, this is the cheapest part of the component. Since you already have the wheel off, let's replace anything so that you don't have to come back here in a month and I have to go replace your races and replace your bearings again. we check the hub, everything's clear and ready to go. What we're now going to do is we need to press these races into the hub. As the bearing guy, I'll first tell you how we would like you to do it, and then we'll talk about how you can do it as, you know, in recognition of what the field's like. As a bearing person, what we would prefer is you try to push this, put a plate on top of this race, maybe use an arbor press, and smoothly push that all the way in. That's what my bearing guy answer is. We realize that's not possible. What we want to avoid doing is hitting directly on the race you're mounting. We don't want to have a punching up against the face here, because what will happen is you can dent in part of the material and you can cause an early failure. If you miss the edge, you can score the raceway with your punch as you're pounding the bearing on. Okay, don't hit the bearing. Well, what am I supposed to do? Have some kind of press tool or tool that you can do all of your pounding on. One of the best I've seen is when you take the old race out, cut it with a die grinder or die grinder like this, weld a plate on the back, and then put that on top of the bearing and then hit on that piece. You can do all your hitting on the old race, and if you should miss-hit or cause damage, it's the piece that you're not going to put in. And that press-on tool then evenly applies force, mounting the new raceway into the hub. It's the best way to avoid damage to the part, and it makes for a nice, easy method for putting in. So as you can imagine, old race right here, bar across the back, welded, and just pound it on. And again, remember to cut through all this all the way so that when you get it pressed in, the press retention force in the hub pushes in and you can easily pull this out. So we'll want to put both races in. After we get the race in, we'll want to check along the back of the bearing up against the flange, up against where you've pushed up against the flange with a 1/1000th inch feeler gauge. And you want to check all the way around and make sure it doesn't go in. The reason for that is we want to make sure this race is pushed all the way in and it's pushed in flush and even all the way around. If you go all the way around and find out it goes in at one point, the race is cocked, and that can result in lower bearing life than you would normally get from a proper installation. So again, push all the way in and check with a 1/1000th inch feeler gauge all the way around. So we have our races on. We then want to put our bearings in, or before we do that, we want to lubricate the surfaces with the same oil that you will be putting into the wheel hub at the end of the installation. The idea behind that is to have a nice surface of oil so that we don't cause any damage to the bearings while we're putting it on the truck. We don't need a lot of oil here, just a shop rag, clean shop rag, wetted down with the oil, wipe it over the bearings, wipe it over the races, put the bearings on into the part. So we've got both bearings in the hub. Now would be a good time to put the seal onto the hub before you put the hub on the truck and have to forget the seal and then take everything off to put the seal back on. Make sure you have your inner seal on, and then we go on over and put it onto the spindle of the truck. So we'll put it on, take our adjusting nut, and get it on there. And this is where we get into RP 618, the actual mounting of this hub onto the truck. Right here we have the RP 618 table, you know, step-by-step progression for what you should do when you're mounting this hub on. Step one, we just did. We lubricated the parts with clean axle oil before we mounted it on. The big note here, at no point should we ever use an impact wrench for mounting this wheel hub. It should always be done by hand. The idea behind that is the impact wrench can tighten stuff on so quickly you can actually damage the bearings before you even get the truck out on the road. So we never want to use an impact wrench when we go about doing this. So we're through with step one. The table is a little bit confusing because step one goes all the way across the top, and then we'll have the next steps one at a time. So step two, our initial adjusting nut torque. In that, we're going to take this, while spinning this wheel, we're going to tighten down to 200 foot-pounds of torque. The reason we're spinning this wheel is to do what we call seating the rollers in the bearing. What is that? Well, in your bearing, these rollers can be very loose, and they can shake around and move around, and they can be cocked. To seat them, by just simply rotating the bearing, the rollers will line up in the bearing and seat in place. If you don't do that, just go through the steps and never rotate the wheel, the truck will go out on the road, it'll start rolling, the rollers will then seat, and what happens is you actually gain end play. So, you'll go through the procedures, you'll assume you're within 1 to 5,000th of end play, the truck goes out on the road, the rollers seat themselves, you get more end play, and all of a sudden there's too much end play in the wheel. Things that can happen with too much end play, the brakes won't work, or they'll wear faster. Or if it's too much, this is where you get the ABS sensor going off, because the ABS sensor will no longer work because there's too much wobble in the system. So this is that classic case of the truck drives to the end of the block, turns around, comes back and says, hey, my ABS light's on. Well, the rollers weren't properly seated in the procedure. So we'll go through, take our torque wrench set to 200 foot-pounds while rotating the hub, and tighten down. So there we go, 200 foot-pounds. What I like to do, give it a few more turns to make sure everything's really nice and seated. You can go either direction. Give it another knock. So we're tightened down really tight. In bearing terminology, we call this preloaded. There's no extra room. For good bearing life, what we want to do is we want to have end play, which is a little bit of slop. So what we need to do now is back off this nut. So step 3, we back off the nut 1 full turn. It's important to note when we get to these back off stages, this is assumed to be a new spindle and a new nut. Over time, over wheel changes, these threads will become distorted and you won't have to back off as much. But the TMC procedure assumes a new wheel hub, a new spindle, new nut. So 1 full turn should get it to where it's spinning freely. So what we'll now have to do, take a general wrench and back off 1 full turn. Basically what we need to do is till it spins freely. And our display stands, as you can see, after barely a half turn, this display stand, which travels around the country and gets shown off and has been used a lot, barely needs that much. So we're now loose. What I like to recommend then, take that nut back to hand tight. That way, if you should be called into the office to discuss something on the last job you did, you have a phone call, it's break time, you don't lose all that work you did seating the rollers in this hub. You don't have to worry about someone coming by and bumping the truck or the truck getting jostled and the rollers shaking off and all the work you did being ruined. So just take it back to hand tight to save your work, so in case you get called away. So we've done our initial back off. Here we'll do our final adjusting torque. And in this case, we're going to want to tighten down, again while turning, to 50 foot-pounds. Again, we're turning just to make sure the rollers stay seated. And we'll take a second torque wrench and set to 50 foot-pounds while turning the hub. So there's our 50 foot-pounds. Not as much. But again, we're in preload. But this is our final seating set. So we're set down. Now we have to do a final back off. We're done with our adjusting nut. And now we want to back off. Here's where the table gets a little complicated. The best way to think about this is each column is a question you need to answer. So column 1 is axle type. Are we doing a trailer wheel? Are we doing a drive wheel? Or in this case, we're doing a steer wheel. So okay, we're only concerned with this portion, this upper portion of the table. We move over to the next column. How many threads per inch on my spindle? The steer wheel is a little bit more complicated. These first 2 are for the D-washer style wheel hub that you see on a lot of the smaller delivery trucks out there. So if you're dealing with that style of wheel hub, that's these 2 right here. For the over-the-road 18-wheeler Class 8 market, it's these 3. So you have to ask yourself, how many threads per inch? Ours here is 18 threads per inch. You then move over to our final back off. Here we are, a half turn. So we're going to back off our adjusting nut a half turn, and that should give us our appropriate end plate. To keep that in place, we then put our washer on, and then we jam, and then we put down with our jam nut. And the easiest is just keep going over 200 to 300 foot-pounds worth of torque to jam on the nut. And then after we get that, what a lot of people don't do, there's a final 8th recommended step, actually measure your end play. This is where we go on and put a dial indicator on and measure the end play. The back-off depends upon what kind of wheel you're working with. Here we have a steer wheel. There's also the drive wheel or your trailer wheel. So what you go, basically for the back-off, it's the next 3 columns. Treat each column as a question. Axle type, what kind of axle am I doing? Here we're doing our steer wheel. So we go down and worry about the steers. Next we move over and ask ourselves how many threads per inch. In the steer one, the first 2 columns are for the single nut cotter pin D-style. The single nut adjustment, what's called the D-type for a lot of delivery trucks. That's where you worry about the first 2 columns. If you're doing your standard class 8 truck over highway truck, that's the next 3. This one is 18 threads per inch. So we have 18 threads per inch on our spindle, and then we turn off, our final back off is a half turn. Again, that half turn assumes a new spindle and new nut. This well-worn spindle will do about a quarter, and that will get us our appropriate end play. What I'll do is I'll follow the TMC procedure, and we'll see what happens when we actually measure our end play. So we're going to back off a half turn. There we go. So we've backed off a half turn. We then want to take our seating washer, slide it on the spindle, and put one of these holes over the dowel on the adjustment nut. If you put it on and it doesn't quite fit, what you can do is you can pull it off, flip it around, and the holes are offset by a half hole. So you can try to put it on again. If at both times you can't get the dowel pin to fit over a hole, find where it's the closest to a hole and loosen to that hole. We never want to tighten. If we're going to have an error in any way, we want to err towards a little bit too much end play as opposed to going into preload. The reason for that is when the truck goes out on the road, the wheel's going to be turning, it's going to heat up, and you're going to lose end play in operation. So we don't want to be too tight to begin with because we're going to go tighter still. So we'll take the washer, put it on the spindle, and lucky for me, it goes right onto the hole, right onto the dowel pin. If it didn't, I would have taken it off and flipped it around, but we're onto the dowel pin, and we're right onto the dowel pin. Then we take our adjustment nut, put it on. So put on our nut, continue over from where you are, and we'll torque down to between 200 and 300 foot-pounds. At this point, you no longer have to be turning the wheel. We'll just torque down between 200 and 300 foot-pounds. And there you are. Now for most of you, this is where we're done. The TMC procedure recommends that we go and check our end play. Many places don't do it. What we are starting to hear is that for those of you dealing with very large fleets, the fleets are beginning to demand that every wheel job you do, they want you to measure the end play. So the question goes out, how do I measure end play? Well, what you're going to have to do, you'll need to set up some kind of stand and a dial indicator for measuring the end play. This is one that we use. A lot of stands have magnetic bases so that you can easily go onto the hub and lock it down, and then you would position the dial indicator for measuring end play. Some of you might be asking, okay, I've started using aluminum hubs, the magnetic base won't work. What do I do? Well, 2 things. As you can see what we've done with our hub right here, we have a steel plate that'll go over 2 of the mounting bolts for the wheel and tighten down, and you can put the magnetic base there and it'll work. So that's where you put your magnetic base. Or, simpler, you can unscrew the bar from the base, and it'll actually fit into the threaded holes, every one I've seen, for your end cap. So you thread it in there, and you get it in place. the main thing what we want to do here, we're mounted to one component, measuring off another. So in this case, we're mounted to the hub, and then we're going to measure off the spindle. This dial indicator is in the thousandth increments, so every little line we have on here is 1,000th worth of end play. I'll try to set it off to 0, and then what we do is while turning and pulling, we'll pull and push. And here I'm getting about 12 to 13,000th worth of end play. What's important to note, if you set it off at the 0, you know, say you go 5 one direction of the 0 and 3 the other direction, it's not 5 minus 3 for 2, it's total movement. So it's 5 plus 3 for 8,000th worth of end play. Here I had total movement of about 12 to 13,000th, which I expected considering how worn this wheel is. Okay, so you measure. You're too high. What do? Well, you don't have to go all the way to the back. You don't have to go all the way to the beginning. What you do, you take off your jam nut. I'll show it right here. We would loosen our jam nut. We would loosen off our jam nut, and then we would tighten the washer one hole. Pull off the washer and tighten one hole. Tighten one hole. Torque back down on the jam nut. Remeasure. Verify you're within the end play. If you're still up, tighten another hole. If you've gone too tight, maybe one hole is too much, you can always flip the washer around and adjust a half hole. But that's how you can adjust to get within 5,000th of end play, just going by the holes on the washer. We've measured, we found we're between 1 to 5,000th of end play. Great, everything's fine. What I would recommend is if you have gone to the trouble to actually measure your end play, take your work order and write down what you measured. Date it and initial it. That way if something should happen and they ask you how do you know you did it right, you can say, hey, I followed RP 618. And not only that, when I measured it, I had 3,000th worth of end play, which is right in the middle of where they want it. So if you are going to measure, definitely write it down if you're going to go to that. Okay, so that's the standard dowel pin washer system. In the industry now, there's a number of single nut washers, or single nuts that are starting to become popular. What do I do in cases like that? What's important to note is the steps will be roughly the same, but how much you tighten down and how much you back off will be different. No matter what you do, refer to the manufacturer's recommendation for what they should do. If you're putting a new nut on, they'll be in the instructions for the nut. If it's a repair job where you're reusing the single nut, just go online and they have it on there. There's a number of different systems, and there's certain things you do have to be concerned about. This particular one right here, it's kind of the TANG-STYLE. What happens is the socket goes over the nut, depresses the tangs, and then you can move it, tighten and loosen it. As you can see, I'm having a hard time. That's because my socket doesn't fully depress these tangs. You want to make sure you have a socket that fits this snugly, because if not, when you torque down, you can shear these tangs off, and that's what's locking this nut in place. So once you shear the tangs off, there's nothing to keep this nut from backing off. So if you do see one of these, make sure your socket fits snugly and fully depresses those tangs in. And it should turn smoothly. Like mine right here, you can hear it clicking as it goes to each spot. So this is not a good socket to use, this one. There's also the Pro Torque. It's a single nut system with a locking washer that goes on. You would tighten it down, back it off, and then you'd take the lock plate and put it in. What's important to note is Pro Torque says this side out, and they'll paint it orange. Make sure you put that side out. Some of the earlier ones, this could be put in backward and it would fit, but it wouldn't lock the nut down. So make sure you have this side facing out is the case. Then there's another one we've seen, the temper lock. Same thing with the washer like that. It goes on, just put it in with snap pliers like that, and away you go. They're all very good systems. Just make sure you follow the nut manufacturer's recommendations as far as how much you need to tighten down, and then back off when you do that. Another difference between the standard wheel hub is the preset wheel hub. Some of you might have encountered this where after you disassemble the wheel, you'll have something like this. This is the spacer that goes between the bearings. It'll fit in right here in the wheel hub. The idea behind this is, in the process of mounting this up, it doesn't matter how much you tighten down on that initial adjustment nut, this spacer prevents the wheel from going into preload. RP618 doesn't apply, it has its own procedure, so follow their recommendation as far as how to mount the wheel. Where we have gotten questions are, for this system to work, it has to have special bearings. And we'll get the question, I can't find the special bearings, they're all out right now, and it's 5-month lead time. Or my customer doesn't want to spend the extra money for the special bearings. Can I use standard? Before we answer that question, let's discuss what's special about these bearings. The hub itself is a standard hub. The nuts are a standard hub, the spindle's a standard hub. It's the bearings that are special. What's special is what's called the stand height of the part. The stand height is, while this bearing's sitting on the ground, how high it is to this port spot right here. That's called the stand height. Of course, there's a tolerance to this stand height. And to make the system work where you can take any of the special bearings and always use the same spacer and only have one set of spacers, we had to cut this tolerance down in half. And that's what makes this bearing special. We have a half stand part. So that as long as you're using these special bearings, you can go ahead and use that spacer, and you don't have to worry about checking with 3 or 4 different spacers. Everything will work together perfectly. But the question happens, okay, I can't get the specials. Can I use standards? The only way you can use the standards is if you take the spacer and throw it away. Just throw it away, forget it was ever there, and then go ahead and follow RP618 with the standard parts. Again, it's important that you take that spacer and get rid of it. You can't use the standard parts and the spacer. Big no-no, can't do that at all. But as long as you throw the spacer away, you're good to go with the standard parts. Okay, so that brings us to the end of the procedure. We've mounted the hub on the truck and achieved the desired 1 to 5 thousandth worth of end play. We've discussed some of the non-standard things you might see out there, such as the single nuts that are becoming more prevalent out there in the industry, and what you have to worry about in comparison to the RP procedure, which deals with the adjusting nut, washer, jam nut. We've also discussed the preset wheel hubs that are becoming more prevalent in what you can see and what you can do if all you can find are the standard bearings as opposed to the specials. Thank you very much and have a good day.